Good morning, Precalculus. Today is Monday, May 4th, and may the 4th be with you. So what we're doing today is we're sort of continuing on the idea of vectors that we sort of started with in Chapter 10. And what we're going into is how can we write vectors? So with this, there's a couple things to know about vectors. Number one being what is known as the unit vectors and magnitude. Now, unit vectors are, right now we're working in two space, so we're working in the xy plane. So we have two unit vectors that basically, one in which acts as our x-axis or x direction, which is going to be our I vector, and then one which acts in our y direction, which we're going to call the y vector. And this is sort of a common terminology used a lot of the time. And so with it, you have the vector I, which is 1, 0, meaning you have a vector that is a distance of 1 in the x direction. And then you have the vector j, which means once again a unit of 1 acting in the y direction. So you can turn any form of vector into a vector notation using this sort of notation. You can either write it as sort of the distance, displacement in x, comma, displacement in y, or as basically your displacement in the I direction plus your displacement in the j direction. And then with your magnitude, because we're dealing with sort of two-dimensional objects, they all act as triangles, our formula we can use is literally our Pythagorean theorem to find the magnitude or the total length of our vector, which just ends up being your I direction squared plus your j direction squared. So with this, we're going to be sort of going into some problems. So down here, I have 10-15, which just started off with, we have vectors with some initial endpoints and starting points, and we'll do this one in blue. We're going to draw the PQ vector. So PQ is a vector between the points 7, 2 and 3, 5. And if we draw that, it goes whoop. So if we think about it, that would be, in terms of a vector, we have PQ vector equals, well, that's -5 and +3, because it goes backwards in the x direction 5 and up 3. So we can write it as -5, 3, or -5i plus 3j. Now, what we need to do next is we need to write the coordinates. So we did that, and we need to write a vector equivalent to that. So what we could do is we could just go really simple for part A. We could go really simple, and we could just start at 0, 0, and then we could go back 5, up 3, and we have a vector equivalent to PQ, which we could just sort of write it out as 0, 0, and -5, 3. And so those are our 2 points, which would make a vector equivalent to our PQ vector. If I could draw in straight lines, it would look a little bit more accurate. But overall, this should be good as it is. And now we'll continue on to part B. So for part B, what we have to do is write PQ in component form, which we actually have already done. And then last but not least, for C, we need to find the magnitude of it, and which will basically use Pythagorean's theorem, or the formula for finding the magnitude of a vector. So with it, if we look at PQ, so if we rewrite our thing, we have, it is -5, 3. So if we do this, magnitude of PQ which oftentimes, a lot of places they do double bars for finding for showing the magnitude of a vector. For me, I just sort of do the absolute value bars to show magnitude, just one single set rather than two sets. As far as I know, it's completely up to preference. I find it's just easier to do one, and if you do the vector hat, then it makes it pretty obvious that you're doing a vector and not just taking the absolute value of a scalar. So when we do this, we end up with equals the square root of first component the squared plus second component squared. So square root of -5 squared plus parentheses 3 squared. And so when we get it all out, we end up having the square root of 34 because you have 25 plus 9, which is 34. And so this would be the answer to this question. Now, what we're going to be doing next is we're looking at vectors given in component form, and we're going to write it in ij. Now, if we remember, the difference being I and j, I is your x component, j is your y component. So for this one, I'll give you a moment to pause the video here and just sort of try it yourself, and then we can double check. If you're confident with it, I believe you'll be able to do this just fine. If not, I'll answer them now. So if you wanted to try them, do so now. So what we have is we have 6 in the x direction and -2 in the y. So since the x direction is the I vector, this would be 6i. And then since it's -2 in the y direction, that would be -2j. And then this one, we're converting into the other form. So this is the coefficient of the I would be your displacement in the x direction, and the coefficient of j would be your displacement in the y direction. So for this one, we have -1, 3. And then for this one, we have 2 in the x direction, so that would be a 2i. And then 0 in the j direction, so we could either just leave it as 2i, or we could say plus 0j. It doesn't really matter which way you do it, whatever works best for you. Personally, I like writing less, so I would just leave it as 2i, but you don't have to necessarily do that. So that's what's going on there. And as we sort of continue on, we're going to talk about changing vectors into component form. So in this case, we have a vector. We have vector v, which has a magnitude of 6 and an angle of 120 degrees. However, what we want to do is sort of convert this from something where we have a magnitude and an angle into something where we just have it in component form. So to do this, if we think about it, if we remember sort of our unit circle, this would be 6 sine theta, and this would be 6 cosine theta, which in this case would be 120. Because we have the angle 120, so we have our cosine, which is related to our x direction, and our sine, which is related to our y. And so when we do this, cosine of 120 would be 1/2. So, but it's in the second quadrant, so that would be -1/2. So we'd have our v vector equals -1/2 times the magnitude, which is 6, comma, well, in this case, this would be √3/2 for the sine of 120. So we'd have √3/2 times 6. And so when we do that out, we should end up with -3, comma, 3√3. Or negative 3i plus 3 root 3j. And so that would be a way you could do it. Now, that's sort of how this example is doing. So it's an angle based off of the x-axis, not bearings like it was done previously in the previous chapter where you're talking about bearings as in sort of directions off north. This is more directions off of east. And that's sort of how we work when we're talking about vectors, is off of east, not north. So that's sort of an important thing when sort of converting into component form. And then in 17, what you're basically doing is you're taking the idea of turning it into component form and you're applying it to, say, something like pushing a lawnmower. So we have a lawnmower right here, and we're applying 50 pounds of force to it. And one of the things we would do normally is draw a vector diagram to illustrate the situation. I, however, have the luxury of just drawing on the image and doing that. And then we're going to resolve the vector into horizontal and vertical components. Now, one of the things to notice is that since this is 45 and it's going this way, what I would like to say is that v equals negative 50, comma, 45 degrees. So in this case, the vector is in negative 50, 45 degrees, because rather than going outwards, it's going inwards. And so one of the things that can happen is you can just sort of flip the magnitude to get a negative vector. Rather than having to add 180 to this, I just will call it negative 50 because it's going inwards and not outwards. So now we need to resolve it into horizontal and vertical components. So what we could do is we have v equals, we'll do negative 50 times, and since this is the x part, we'll take the cosine of this angle, 45 degrees, comma, and then with the next one, we will do, once again, the magnitude, which is negative 50, times, and since we're in the y coordinates, we take the sine of 45 degrees. And so as we do this, we would get it as v equals, this would be root 2 over 2, so we end up with negative 25 root 2, comma, negative 25 root 2. So this would mean that for this thing, for this lawnmower, we're pushing at negative 25 root 2 pounds of force in the x direction. So we're pushing sort of backwards, and then we're also pushing down with the same amount of force. So since we resolve this into components, if we think about which one's doing the useful work, well, we don't really want our lawnmower to be going into the ground. So if we sort of think about in terms of vertical and horizontal, the vertical components are kind of worthless. So we can just sort of be like, we can just label it as such. We can just call it worthless. It's fine, they're numbers. They don't have self-esteem. So this one's worthless work. So to be perfectly honest, if we're to push sort of straight on from ground level for D, well, we could just push with this amount of force horizontally and we'd be good. So we could just say 25 root 2 pounds of force. And to be perfectly honest, physics is one of the places where vectors end up becoming very useful very quickly. And same with parametric equations, which we'll learn about more. As for what I need you all to accomplish, it sort of comes down to a few different things. For right now, what I would like you all to do is you have a few problems today from this sort of learning and understanding section, which I believe goes up to 21, I think is what I assigned. No, 10-20. So we've done 10-15, 10-16, and 10-17. And you have a couple more where there's a little bit more reading of just some terminology such as opposite, zero, and unit vectors as sort of information to use, which it's all sort of under these vector operations. And scalars. So that's what's going to be going on. So you're going to be doing, so I'll do it in purple. And we'll just write it right here. So complete (10-15) to 10-20. And tomorrow, I've sort of simplified how I'm doing the assignments. So we're spending 2 days on each sections, since it seemed like it was a little bit too much, based on what I polled, I was giving too much homework, or you were spending more than an hour per day, or the majority of you were spending more than an hour per day on assignments. So what I'm doing is sort of doing a combination. We're working on the same section twice. So hopefully, so today we're working on the learning portion, and then tomorrow you'll be working on the review and preview questions, which in both cases there's about 5 or 6 questions. So I'm hoping that by that you end up spending less than an hour 30 every 2 days, which sort of puts it in the range of amount of time I want you all to be working on these things. And then hopefully by the end of this week, I will be able to give you information on the final project involving parametric equations and sort of drawing something on Desmos, utilizing them. I may do groups if we can, but that might be a little bit harder. But we'll see. We'll try and figure it out. So that's the end of this episode. I hope it was useful, and I'll see you all later.